Hi, in this video, we are going to talk about one of the commonly asked interview question. So this is a question that could be solved by binary search approach or which is also a divide and conquer approach. This particular problem can be solved by using divide and conquer approach and binary search approach. So binary search approach obviously is divide and conquer. So it won't be directly used, we won't be directly using binary search, but we will have a small twist to it. So first let us try and understand that what is the problem statement, and then we'll try and come with the logic, and then we'll write the code like we do always. Okay, so let's first try and understand the question. So the question says find the given element in sorted and rotated array. Okay, very small problem statement. So basically you are given an element. So let's say here the key is the element. What you have to do is you have to find that where this key is in this particular array. Okay, in this array. Now the thing is that this particular array is sorted, but it is rotated. So till now, if you're solving question of divide and conquer, you must be very much comfortable with the fact what is a sorted array. So basically this is an array arranged in ascending or descending order. In this case it's ascending, but it is rotated. You might be knowing rotated, we have had it in the previous videos as well, but in case you are not aware of it, let me tell you what is rotation. So let's say we have an array 1 2 3 4. Let's say this is the sorted array. So we can either rotate the array leftwise, we can either have left rotation or right rotation. So when we have a right rotation, what we do is we rotate the array in this particular manner. So let's say if I rotate it by 2 places, you always have to tell that okay, you know how many places you are going to rotate. So let's say we rotate it 2 places. So in that case my array will look something like this: 3 4 1 2. If I would have rotated it just once, it would have looked like 4 1 2 3. This is right rotation. In case of left rotation, the rotation will happen in this particular way. So if I rotate it just once, my array will look like 2 3 4 1. So this is right rotation, this is left rotation. Okay, so in this case it's not given that whether it is right rotated or left rotated, but honestly the logic that we will come across with will work both for left rotation and right rotation. So if you have understood the question, first I'll suggest that try this question on your own. I have already given you the hint that you have to use divide and conquer, you have to use binary search. You just have to apply a bit of twist, try on your own, and then you can come back and see how we are solving it. So hope you have tried this problem on your own, and hope you came up with the result and you're just here to revise and see what we are trying. And in case you haven't, don't worry, we'll just try and solve the problem. So basically here we know that if this would have been just a sorted array, then we would just have to just go ahead and apply the binary search. We could have done that, but here we know that array is rotated. When I say array is rotated, can I say that here we have two parts of the array that is sorted? So if you see that, if we see this part of the array and this part of the array, both of them are sorted separately, right? So if I have to apply my binary search, maybe somehow if I find out that this particular key lies in this particular area or this particular area, if I somehow find out this particular thing that it has to be in this particular subarray or this particular subarray, I would just have to apply binary search in that particular subarray. Okay, so let's just write it down. So we have like two subarrays that are sorted, and our key lies in one of the subarray. So before I go ahead and decide that my key is going to be in this array or that array, the very first thing that I have to decide, what is that particular point from which the array is rotated. So here we know that, I'm seeing it manually from my eyes. I know that okay, this part of the array is sorted and this part of the array is sorted, this complete part actually, and this complete part. But first I have to find out, okay, what is that particular place after which we have this particular sorted array and that particular sorted array. So this, we can say that this is a pivot point, right? So I need to find out that what is that point after which the array is sorted and before which the array is sorted. Okay, so we will see how do we find the pivot point. But let's say once we have the pivot point, what we will do is, the steps that we have is find pivot. Okay, check if element exists before pivot or after pivot. apply binary search on corresponding part. Okay, so this is what we have to do. Now here we have two problem statements now. The first one is to find the pivot, and second one is to find that if element exists before the pivot or after the pivot, or even the pivot could be the element. In that case, we will simply return the pivot. And we already know that once we have the sub-array on which we have to apply binary search, we can apply binary search. We already know that, okay? So let's just see first that how do we find the pivot, okay? Now let's go ahead and try and find out the pivot. So when I say pivot, in this case, the pivot is 10, okay? So how do we find out the pivot? Let's just take two more arrays as example, and that will help us in finding out the pivot, okay? So let's say one of our arrays is 60, 70, 80, 90, 10, 20, 30, 40, 50. Okay, this is one of our arrays. One of our arrays, let's say, is 60, 10, 20, 30, 40, 50. Okay, let's say this is one of our arrays and this is one of our arrays. So let's say in this particular case, what we will do is, in order to find pivot again, we will use the binary search only. So let's see, for binary search, what we have to do is we have to have a condition based on which we will reject one of the part of the array and we will go ahead with our binary search with other part of the array. So let's say in this particular case, first we'll go ahead with it. This is the pivot. So I have to find out this one. So first, we know what we do in binary search is we calculate a mid. So let's say I calculate my mid. In this case, we have 0, 1, 2, 3, 4, 5. So let's say our mid is 2. Now, what we have to check is, so let's say this particular array. In this case, this is mid. So as you can see that in this particular case, we check that if a of mid is greater than a of mid plus 1, if I know that this is greater than this, which should not be the case in ideal sorted array. In sorted array, the next element should be greater, but here that is not the case. So if this is greater than this, which means that this is my pivot. So this was mid. In this case, we have returned mid plus 1. So I get my mid. So I get my pivot. So in case we have a mid and the mid satisfies this particular situation, we simply return mid plus 1, okay? Now we have another situation. In this case, let's see, we have 0, 1, 2, 3, 4, 5. So in this case, our mid is again 10. Now what happens in this case is, if we check that if mid is greater than mid plus 1, that is not the case, this becomes false. But if you see the previous element is greater than this element, right? So in case of sorted array, this wouldn't have been the case. So if the previous element is greater than this element, which means that this is my mid. So we have another situation that if a of mid minus 1 is greater than a of mid, we have our pivot as mid. Now these are the two situations in which we get our mid. Now the case is that in this particular case, our mid is 2 and it is not following any of these conditions. None of the conditions are true for this mid. Now the question is whether I should continue my search of pivot from this particular part or in this particular part, right? This was my mid. So now we know one thing, that there will be two parts of the array from here. One part will be completely sorted and another part will be unsorted, and that will be the part having the pivot. So as you can see that here the array is sorted and there is no chance that pivot could be there in this particular part of the array, right? And you can see that there's another part that is not sorted and the pivot could be here. So how do we know that which part of the array is sorted? So now we will check that if first element of the array is less than this particular element. Okay, so if this part of the array would have been sorted ideally, then this value should be less than this value, right? So let's say a of 0 is less than a of mid, which means that this particular array is sorted, this particular part is sorted, my pivot will be in this part of the array. But here the case is opposite. So what will happen is that if this particular condition becomes false, that means that my pivot is in this part of the array. So what we will do is that if this particular condition becomes true, we have to search for our pivot in this particular half. So we will call the pivot function, let's say we call it pivot a comma, we change our low and high. Our low changes from low to mid plus 1 and our high remains the same. Okay, and in other case what will happen is that if this is true, this is the case, else our pivot will be in the first half. So we will have a comma low comma mid minus 1. So now these are the conditions using which we will be getting our mid. This is one condition, this is one condition, this is one condition, and this is one condition. So these are the conditions using which we will get our pivot. And now what is going to be the base condition? The base condition remains the same as it is of binary search. What will happen is that it might be a case that our complete array is sorted and there is no rotation. In that case, we won't have any pivot, and the base condition will be that if low is greater than high, we simply return minus 1. Okay, so we have seen till now that how do we calculate the pivot. We will just go ahead and write the code and run it as well. Before that, we will go to the second part. So finding the pivot was the first part. The second part is to check if element exists before pivot or after the pivot. Let's just go ahead and see that once I know where is my pivot, how do I decide that I have to do my binary search in the first half or the second half. Okay, so once we have found out our pivot, the second part is easy actually. So let's say here the key is 55. Okay, so now this is my pivot. I will check that if 55 is greater than this first element or not. I'll tell you what happens. I'll check if 55 is greater than this element or not. So one thing is there that this was a sorted and rotated array, and this is one part of the array, okay, that is sorted. And if key is greater than first element of this particular array, which means that all the elements before this was less, right? All the elements before this were lesser than this particular element, and that is what there in this part of the array, which means there is no chance that 55 could be there in this part of the array. There's a high probability that 55 will be in this part of the array. So what I have to do is I have to simply apply my binary search in this part of the array. So for, let's say, safe side, let's take k equal to 60. So in this case, we'll have to apply binary search in this part of the array. And once we do that, we will simply go ahead, do a binary search, and we'll find the element. So what we have to do simply, I'll write it down. We check that if one situation is that the pivot in itself is the key. I'll check that obviously. If pivot is equal to key, I'll simply return pivot. Okay. Another situation that we have is, the situation should come even before this, is that if pivot is equal to -1, which means the complete array is sorted. In this case, we will just apply the binary search in the complete array. So we'll have binary search, we'll pass the array, we'll have the low, and we'll have the high, or you can say start and end. Okay. The other option I have is that I'll check if a of 0 is less than equal to the key. In this case, I'll call my binary search in first half of the array or before the pivot. 0 comma pivot -1. Else we will simply call it in the second half or after the pivot. Return binary search. So this is how the things are going to happen. Let's just go ahead and write the program properly with syntax and everything. We will write it first for finding the pivot, and then for this find key, and then we'll run the code and see how it is working. Okay, let's just go ahead. So now we will just go ahead and write the code. So we already have written the binary search code because this is a standard code. We have already seen it several times. Okay, we will focus on finding the pivot and finding the key. Let's just go ahead and do that. So let's first find the pivot. So in case of pivot, the return type is int. We'll be returning the pivot, and we'll have the parameters as the array, the start and the end. Okay, the base condition is if start is greater than end, we simply return -1, else we have mid is equal to the formula that we use all the time. Okay, we will check that if mid is less than end and a of mid is greater than a of mid plus 1. In this case, we will simply return mid plus 1. So here why we are checking mid should be less than end? Why? Because we are doing mid plus 1 here. So it might be the case that the mid that we are talking about here is the last element of the array. In that case, if we try and do that, we will go beyond the array element and we'll get the exceptions or runtime errors. Okay. So now this is one situation. Another situation that we have is if mid greater than start and a of mid is less than a of mid minus 1. In this case, I'll simply return my mid. Okay. Now let's say if these two are not the situations, what did we see? We will check that if a of mid is less than a of start. This means that first half of the array is unsorted and we can have our index there. Okay. So we will simply return find pivot. We'll call the function again a comma. Now we have to search it in the first half of the array. Okay. So what we will do is a comma, our start remains as it is and our mid end becomes mid minus 1. Okay. If none of these is the case, we'll simply return find pivot a comma mid plus 1 comma end. Okay. So this is how my code is going to be. Okay, I missed a semicolon here. Okay, so this is how my code is going to be for find pivot. So let's say I found the pivot. Let's just use that in find key. So in find key, what we will do is, first thing we will do is we will call the find pivot. So let's say we have int pivot is equal to find pivot a comma 0 comma n minus 1. Okay. Now we will check that if pivot is equal to -1, we will simply call the binary search for the complete array, binary search a 0 n minus 1. Else we will check if a of pivot is equal to the key. In this case, I'll simply return the pivot. So I'm just returning the index. Okay. And then we have if both of these are not the cases, we simply have to now search it either before the pivot or after the pivot. Let's see how we can do it. So we will check that if a of 0 is less than key or the key is greater than a of 0, which means we have to search in first half. So we will simply return, it's going to be written here, return binary search. Okay, binary search is looking for key as well, so we have to pass key as well, key comma key. So we have to in this case just pass 0 comma pivot minus 1, and if this is not the case, we'll have our search in the second half. Okay, so this is my code. Let's just run this code and see if things are working fine. So now we will try and run the code. So first we have to give the number of test cases. Let's just give 4. We will see how many variables we'll put in. So let's say we have size of the array is 5 and we have elements as 2, 3, 4, 5, 1, and the key that we have to find out is, let's say, 5. So as you can see that the index we get is 3, 0, 1, 2, 3. Okay, let's try some more test cases. So let's say we have 8, we have 60, 65, 70, 75, 80, 10, 12, 35, and let's say I have to find out 12. Okay, so we are getting 0, 1, 2, 3, 4, 5, 6. So I'm getting the right index. Let's just try one more. We have the same thing we will do: 60, 65, 70, 75, 80, 10, 12, 35, and let's say in this case I have to find 65. So as you can see that we are getting the right answer. So we're getting the right answer for most of the test cases. Make sure you try this code on your own, and if you haven't understood anything, make sure you watch the video again. You try things on your own. It is really necessary, and that will help you in solving the questions going forward. And since we are using binary search here, the time complexity for this is going to be O of log n.